Here is one of the reasons why we care about identity matrices. We say that a square matrix A is invertible if there is another square matrix C such that CA is equal to AC is equal to I. If it is possible to find such a matrix C, by the way, sometimes it is impossible and we will discuss it. But if it is possible to find matrix C that satisfies both property number 1 and property number 2, then we say that A is invertible. We call C inverse and we denote it by A to negative 1. Important. A to negative 1 has nothing to do with 1 divided by A. Same notation, but completely different meaning. By this, we denote a matrix C that satisfies property number 1 and property number 2. For example, here's matrix A. Let us show that this is A inverse. Here's how we show it. Multiply A by A inverse. We get I. We multiply A inverse by A, we get I again. So what is written here is inverse of A. Guys, any questions here?
Can you take the inverse of a non-square matrix?
No, we cannot find inverse of a non-square matrix. Other questions?
If we have a non-square matrix and so we want to find, like, it's not possible to get I from that, correct?
Well, yes and no. First of all, if A is a non-square, let me go back to one of the examples. Say, take a look at this. A is non-square matrix. B is non-square matrix. However, their product is a square matrix, correct? You may ask me a question. So suppose A is a non-square matrix. Is it possible to find C such that CA is I? By the way, for some non-square matrices, yes, it is possible. But what is impossible, one can show that if A is a non-square matrix, it is not possible to find matrix C such that both properties are true. Does this answer your question?
Yes.
Other questions?
I have a question.
Yes.
So in this example, C is an inverse of A, but does it work the other way where A is an inverse of C?
Yes, one can show that property number 1 implies property number 2, and property number 2 implies property number 1. But this is a theorem. Therefore, in definition, we do both.
Okay, thank you.
Other questions?
I have a question.
Yes.
So the only thing that makes a matrix an inverse of another one is that multiplied together, it's an identity matrix.
Exactly.
So could one matrix have multiple inverse?
No, one can show, very good question. One can show that if A is invertible, its inverse is unique.
Okay, thank you.
Other questions?
If we found that A was invertible,
yes,
would C always be the inverse of A?
Give me a second. So it's basically, what do you mean by always? Invertible means there exists matrix C such that AC is equal to CA is equal to I. Therefore, I'm not sure if I understand your question.
Yeah, so say we did find a matrix C.
Yes.
And A was invertible, would C always be A -1 or the inverse
well,
of A?
it's not like always. If matrix C that satisfies both properties exist, we can denote matrix C by this.
Oh, okay.
Just a new notation. Did I answer your question?
Yes.
Mhm.